The last unit that we're going to study is one on statistics. So in section 12.1, we start out talking about what does statistics mean. And many people think that statistics is the same thing as data. In your book, though, it reminds you that, however, statistics has a second meaning. Statistics is also a method for collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. This methodology divides statistics into two main areas. Descriptive statistics is concerned with collecting, organizing, summarizing, and presenting data. Inferential statistic has to do with making generalizations about and drawing conclusions from the data collected. So we are going to just do a very brief study of statistics. There certainly are full courses on statistics, in fact, full degrees on statistics, and we're just going to scratch the surface. All right, we do need to understand a little bit of vocabulary, so once in a while I'm going to grab something out of your textbook. And here's the statement that says, consider the set, which is like a collection, of all American TV households. That's all the households that have a TV. Such a set is called a population. In general, a population is the set containing all people or objects whose properties are described and analyzed by the data collector. And a key word there is all. Now, it would be very, very difficult to study all about most things. So instead, we look at samples. And a random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. So, like when advertisers want to know what people think of their products, they don't interview everyone in the United States. They pick what they call a representative random sample. All right, moving on, just trying to make sure we all have the vocabulary down. The data that we collect can be organized and presented in a variety of ways. Frequency distributions, grouped frequency distributions, things called histograms, frequency polygons, and something called stem and leaf plots. We're going to look at some of those. A piece of data is called a data item. And this is from your book, so it mentions a few things that we can't really talk about. It has an example right here, but moving on, collected data can be presented using frequency distribution. Such a distribution contains two columns. The data values are listed in one column. The numerical data are generally listed from smallest to largest. The adjacent, the next door neighbor column, is labeled frequency and indicates the number of times each value occurs. Let's take a look at our first question, which shows a frequency distribution. All right. A questionnaire was given to students. The first question asked was, how stressed have you been in the last week on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible? The responses are shown to the right. All right, so stress rating of 0, 6 people identified themselves in that category. Stress rating of 1, 4 people, 2, 1 person, and so on. Okay. Which stress rating described the greatest number of students? So here are the stress ratings. Where's the greatest number of students? Well, the greatest in the frequency is 32, and that is stress rating 8. So it was 8 out of 10. How many students responded with this rating? And the answer, we've already said it, is 32. Okay, so that was just an exercise to look and see what a frequency distribution is. Let me make this a little smaller so we can see it all. There we go. Number 2, a random sample of 30 college students is selected. Each student is asked how much time he or she spent on homework during the previous week. The following items in hours are obtained. So one person said, I spent 16 hours, somebody said 20 hours, 21 hours, 25 hours, and so on. Construct a frequency distribution. All right. How many people reported that they studied 15? Well, I'm going to mark them off so I know that I've used them up. So that's 1, 2, 3. The frequency there is 3. How many used 16 hours? 1, 2, 3, and that's it. 3 people reported that. 17. I have 1, 2, 3, 4. 4 people reported that they studied for 17 hours. 18 hours. Nobody reported that they studied 18 hours. 19 hours. 1, 2, 3. 20 hours. 1, 2, oops, I need to mark them. 1, 2, 3, 4, 5. We are building a frequency distribution. 21. 1, 2, 3. 22 hours. 1, 2, 2 people. 23 hours. 1, no, there we go. 1, 2. 24 hours. 1, 2, 3. That'll be a 3. And 25 hours. 1, 2. All right, we have filled in the frequency distribution for a set of data. You just have to make sure that you actually get everything accounted for. Let's look at number 3. A professor has students keep track of their social interactions for a week. The number of social interactions over a week is shown in the following grouped frequency distribution. Identify the lower limit of the second class. All right, so a little bit more definitions. Each one of these is a class. The small value is the lower limit, and of course the big one is called the upper limit. All right, identify the lower limit of the second class. All right, so we need to be focused right here, and the lower limit here is 40, and that's all there is to that question. It's just checking to make sure that you understand when they group frequency distributions, these are called classes. right? Let's look at number 4. It says a professor had students keep track of their social interactions for a week. The number of social interactions over the week is shown in the grouped frequency distribution. What is the class width? All right. The class width is equal to the upper limit minus the lower limit. And it has to turn out to be the same no matter where you check. So you could check any one of these. I could check the first one, and it is 16 minus 10, which gives you a width of 6. Or I could have chosen this one, 65 minus 59. It still gives you 6. All right, you probably noticed that this is gone, and that's because as I was doing it, I was thinking, I think there's something wrong with what I'm doing, and there was. I apologize. I'm going to see if I can edit this video and take out the mistake, but if not, you've seen it. The class width, you could do what I just did, but you're going to have to add 1 to each one of those, because if you count from 10 to 16, their difference is 6, but there are 7 items there. So actually what they usually say to do is take the lower limit of a class and subtract the lower limit of the next class. So we could have done what I started doing, but we would have to add 1. We could take a difference. We could say that the width is 16 minus 10, but then we just have to remember to add 1. And it was starting to feel weird to me because I knew it was supposed to turn out to be 7. So what you're supposed to do is let's change this so it'll work out better. Let's put previous. Okay, so let's pick one, a lower limit. 45. The lower limit of the previous one is 38. And that gives you 7. Okay, pick 2 more. 73 minus 66 is 7. All right, so if you're going to find the width, 2 ways to do it. You can subtract the upper minus the lower, but you have to remember to add 1 to it. Or you can take a lower and subtract the previous lower. You could do it with the highers. You could take 30 minus 23 would still give you 7. Okay, so that's class width. The answer is 7. Sorry, I kind of messed it up. Number 5. A professor has students, okay, same thing. Let's go to the question. How many students had at least 60 social interactions for the week? Now, if you have 60, you have at least 60. All right, so looking here at my number of social interactions, this person had 5. These people had 5. That's, I'm sorry, 5 people had these. 4 people had these. 1 person had these. 2 had these. So, at least 60 would be 5 plus 4 plus 1 plus 2, which will be 12 people. I added up the frequencies of the categories that satisfied the condition. All right, new kind of problem. As of 2003, the following are ages at which the U.S. presidents were inaugurated. Okay. Construct a grouped frequency distribution for the data. Use 35 to 39 for the first class, and then use the same width for each subsequent class. All right. Well, they actually have those for us. All right. We're going to count from our table 35 to 39. So I'm scanning 35 to 39, so in the 30s. And there are 0. 40, whoops, I'm so sorry. 40 to 44. 40 to 44. There's 1. There's 2. And there are exactly 2 in that class. 45 to 49. 1, 2, 3, 4, 5, 6. 50 to 54. All right, 50 to 54. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 55 to 59. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I had 12. I count these twice so that maybe I'll get them right, and I had previously counted it as 12. 60 to 64. 1, 2, 3, 4, 5, 6, 7. 65 to 69. All right, how many presidents were inaugurated at that age? There's 1, 2, 3. And how many were inaugurated when they were age 70 to 74? And I don't believe I have anything left. It is 0. I think it's a little bit more challenging to fill in a frequency distribution when it's grouped because you have more to look for and you have to be careful. All right. Let's take a look at some more ways that data could be described. All right, we've got our frequency distribution, and we can make it a little more visual by putting it into what's called a histogram. And a histogram is really very much like a bar chart, a bar graph. So these aren't labeled, but along the bottom we have the stress ratings, 0 through 10, and then going up is the frequency of people that chose them. So to find this, we would say, okay, which of these represents this data? Well, when the stress rating was 0, were there 3 people? All right. 0, 0. Can't be that one. 0, 20. Can't be that one. 0, 10. Well, it can't be that one. 0, well, that's less than 5, so that might be 3. Let's check some more. 1, 1. Well, there's kind of a line there. 2, 2. Okay. 3, 10. 4, a little over 10. Yes, 11. 5 is the same. 6, 17. Yes, that's over that little tick mark, which is 15. 7 is 26. Yes, that looks about right. And I can check all of these, and this is the only one. Now, I was pretty lucky that I could find an error by simply looking at the first bar. A stress rating of 0 should have had a frequency of 3. This one had a frequency of 0, this one had a frequency of 20, this one had a frequency of 10. So I was able to mark those off right away. Now, another way is what's called a polygon, where you just plot the frequency and then you connect them with little segments. All right. Once again, 0 is 3. That's it's very hard to see. This one starts before 0. Those all start before 0. That kind of bothers me. So let's see. Oh, okay. They were supposed to start at 0, 0. And then they were supposed to start in the corner and go to the first one. All right, 0, 3. That really looks okay. 0, 20. No. 0, well, that, I can't tell. Looks like about 5. 0, 0. No. All right. Let's pick another one to look at. Let's look at stress rating 10. There should be up to 20. So 10, go up. That one's at 20. 10, oh, that one's at 20 also. Let's back up. Let's look at stress rating of 9. That looks like it's about at 10. So they both look the same. Where do these two differ? And we'll check there. 1 and 2. 1 and 2. So this one should be at 1, 1 and 2, 2. 1, 1, 2, 2. I think it is this one. It is really very difficult to tell. They are very similar, but I believe that it is this one because these appear to go almost down to 0 again. If you were doing this in my math lab, you could blow this up and it would be easier to tell. In fact, it's easier to see it just doing that. Let's look over here. Yes, those did not come up like they should have. So I should have been looking at it a little bit larger. So you can blow those up in my math lab and see them more easily. All right, we've got something similar, but now I know to blow up my polygon so that I can tell. All right, these have classes, and they are calling the classes A, B, C, D, E by letters on the grid, on the graphs. Okay, That, I guess, makes it a little bit easier rather than putting down here 45 to 49 and putting here 50 to 54. All right, in the first one, the first class is the frequency 8. Well, that looks like it could be 8. That is not 8. That looks like it could be 8, and that is definitely more than 8. I've narrowed it down. All right. Let's look. B is 18. B, 18, that looks right. B, 18, yes, that looks right. Where do they differ? That's where I'm going to go. Let's go to G. Let's go to Class G. Class G is 5. G, they don't have anything. It cannot be this one. Is G 5? Yes. Is I 0? Yes. So I will choose this one. Okay. Now, I need to be able to see my frequencies, but I may blow these up. All right, A is 8. So A is 8, yes. That's above 8. A is way too low, it's 4. A is 8. So it's either the first one or the last one. Let's check our 0. Up here, I is 0. I, oh, not 0. I, 0. It is this one. I didn't even have to blow it up. But once you've found, you mark them off as you find that they are not the right height. All right. If you've read a little bit in the book, you have talked about how you can mislead people by your visual display. So let's take a look at this one. This describes the world, and it's a little hard to see these. I think this is 1904, 1927, 1960, 74, 87, 98, 12, 26, 2043. All right. What is misleading about these? Okay, so in the year 1904, there was 1 billion. And in 1927, 2 billion. 1960, 3 billion. All right, now this is not on your traditional x-axis, y-axis. It's written here, it's very pretty, but what's wrong with it? So if you look at this more closely, let's see. The sizes of the bars on the vertical axis are not scaled proportionally in terms of the data they represent. Well, in other words, does this look like 1, and that would be 2, and that would be 3, and that would be 4? They look correct. Part of the time frame on the horizontal axis has been cut off. I don't see I see all of them. The title does not explain what is being displayed. World population in billions. No, I think it's pretty clear. Time intervals on the horizontal axis do not represent equal amounts of time. From 1904 to 1927 is what? 23 years. But from 1927 to 1960 is 33 years. And then from 1960 to 1974 is 14 years. It makes it appear that this is happening on regular intervals, and it is not. That is what is misleading. On a graph like this, it would be, here would be a mark, and then here would be a mark, and then here would be a mark way over here, and then another one close, and yet they are evenly spaced. So that's what's misleading. It's the horizontal axis and the placement of those. All right, last one. We have a circle graph, sometimes called a pie chart. What's misleading about this? All right, Look at it, percentage of the world's computers in use by country, and these are some countries. The title does not explain what is being displayed. I think it's a clear title. The chart is too small. I don't have any trouble reading it. The colors are too light and distort the data. No, I think the colors are nice and vibrant. The percentages do not add up to 100%. And that's it. If you add 29, 4, 4, 5, 6, and 9, you do not get 100%. And it had already kind of bothered me because I saw that half of this circle was red, which should have said 50%, and it says 29%. So this is not at all valid to be using that circle graph. The percentages must add up to be 100% if your data is displayed in a circle graph or a pie chart.